In this video, we are looking at the solutions to homework 1.03, number 3, simplifying rational expressions with common monomial factors. So these are going to be common factors that we can cancel. They are in the entire term. So here, Mason and Minjun manipulated the rational expression 32x to the fourth plus 16x cubed over 32x to the fourth plus 48x cubed. Their responses are shown below. Which student wrote an expression that is equivalent to the original expression? So if it's equivalent, that means we can cancel common factors. Now 32, 16, and 48 are all multiples of 16. So we can pull out a 16x cubed from both the numerator and the denominator. That leaves our first term as a 2x and our second term as a plus 1 in the numerator. And in the denominator, that is a 2x plus 3. So Minjun has a form that is equivalent to the original. Now it does have a point that is different. The original is undefined at x equals 0. We actually have a removable discontinuity there. In the equivalent expression here, that has been removed. So it's equivalent everywhere except x equals 0. Khan Academy does not make a big deal about that exception, but it is relevant. So here we want to simplify the rational expression. So we see that every coefficient has a common factor of 2, and that the lowest exponent of y is 3. So we will cancel our 2y cubed from everything. That leaves our numerator at 1, and our denominator at y plus 8. And now we need to find which values of y make the expression undefined. So where are we dividing by 0? Y equals negative 8 is the obvious one. We also have a discontinuity at y equals 0. Just because it's allowed in this final version doesn't mean it's allowed. It was not allowed in our original. We have to retain that removable discontinuity. So another case where you want to simplify the following rational expression. Now this, we may have a couple of stages. So with this one, I am going to break it out in steps. So the first thing we'll do is recopy this to our whiteboard. Now everything here is a multiple of z, and in our numerator, we also have a common factor of 4. So our numerator, we can factor out that common 4z, which leaves us with 3z plus 5. And in our denominator, it's only the z that we can factor out. So we can cancel one z with the understanding that z is never allowed to be 0. And that leaves us with a 4 times a 3z plus 5 all over z plus 2. Now that we have that transcribed back into our Khan Academy assignment, we need to find the values that make this undefined. Z equals negative 2 is where z plus 2 equals 0, but again, we must retain that z equals 0 common factor. Finally, Hannah and Omar manipulated this expression, which does have a common factor of 19 in every term, and the responses are shown below. Which student wrote an expression that is equivalent to the original expression? So Omar appears to have kept just the leading terms and crossed out the 38n squared, which is tempting, but we cannot do that. We cannot just cancel when there's addition signs. So whatever we do, it's got to be after factoring out a common 19n squared. That is common in both numerator and denominator. Now the numerator, when you factor out a 19n squared, does become n plus 2. The denominator does not become 3n plus 2. It becomes negative 3n plus 2. So neither Hannah nor Omar were able to come up with the right solution in this case. So those are the correct solutions to assignment 1.03, number 2.